Hey everybody, so today is the first day of my new DIY CNC build, so let's get started. Alright, so here is my design of my CNC machine. Obviously it is based off of T-slot because that is what I can get my hands on at the moment. So I have a 3D printer and it works pretty well. So my idea with this design is all the custom parts here, these pieces, all these plates, I will 3D print for now. And then when I get the machine built, I'll go back and remachine all of them out of aluminum. Figure that will be better, stronger, but it'll also give me a good opportunity to learn a little bit out of machining. So hopefully it can handle it. Few things that I'm a little concerned about now that I'm deep into the process here. So I've designed a little brushless spindle here. I'm pretty familiar with RC planes and quadcopters and things, so I thought it was a really good fit rather than just getting a brushed DC, like a Shapeoko quiet cut type spindle. I figured why not try and make one that will be a lot more powerful. So this little motor here is about an 800 watt motor, but I do not have RPM feedback, and I also only have one power supply at the moment that's a 360 watt power supply. So we'll see how that goes. We might get a bigger motor, we might need more power supplies, we'll see. I've also got some axial bearings inside there with an ER16 tool holder. The other big part of this design is it is based off of these Adafruit linear rails and cars. So it should be very rigid and precise that way. The other thing that I have a little few concerns about is my axes will be driven by GT2 belts. Now that could be bad, it could be good. It's definitely cheaper than ball screws. So if we need to upgrade to ball screws down the road, then we will. But yeah, that is the gist of it. Oh, and the table. So for now, I'm just going to have to rig up like a wood or a plastic table or something until I get the machine fairly built pretty good. And then we'll go back and build this, drill all these holes with the machine. And this plate will be aluminum or steel. I have not yet decided. I'm thinking I might as well just go with steel on this plate, since it'll be more rigid and I'll get less flex out of it, but it will definitely be harder to work with, harder to drill all these 150 holes or whatever it is. So we might end up on aluminum there, but we will see when we get there. Okay, so here is a bunch of the parts for the machine all the way down. So we have a bunch of bolts on stainless steel so we don't get any rust. We have a bunch of our 3D printed parts, nice and pink. That's all I had left. Well, that's all I wanted to use and get rid of, so that's what it is. Almost done 3D printing there. We're printing a couple more pieces in that enclosure there. We have our linear rails and cars from Adafruit. They are 4-race ball bearing cars. They're very nice. Bunch of pulleys for the belt. We got our GT2 belt, end stop switches, some little rubber feet. Hopefully that'll work out. I picked up this vise off eBay for about $100. Toolmaker's vise, not a normal vise, but hopefully it works out. Kind of the budget model, I guess. We've got our power supplies and electronics. These are Aztec electronics. It was recommended to me to use these electronics to be able to control these 2 amp NEMA 23 stepper motors. I also picked up a Cool Mist misting air cool unit for metal or just for getting rid of debris. We have our little motor here for our spindle. right there. It can go about 10,000 RPM if it's geared directly, but I'm going to do about a 2-to-1 ratio, 2.5 to 1. So it'll be about 5,000 RPM full speed. We have our speed controller. We have our ER16 spindle shank, I guess we'll call it. And our bearings that I'll have to figure out how I'm going to press onto there because it's a very tight fit. End stop switch, T-nuts and brackets, and bunches of T-slot. Alright, so I think we're going to start out with the column. There's all the T-slot for the column. And here's the top and bottom plates to hold it all together. So I chose to print all of my 3D printed parts out of PLA because it's a lot more rigid than ABS. It's kind of what we're going for, is rigidity here, so hopefully that works out. So my 3D printer tends to print holes a little small, so we'll pre-drill all these for M5 clearance, for an M5 to be able to go through them. So we'll use number 6 drill, that's all I got, to clear those for an M5. Just deburring all of these holes. Plastic likes to leave a little ridge when you drill it out. Done. Alright, next up we need to tap all of this T-slot, well, most of it, all of it but the bottom side of the shorter ones, the 590s here, so that we can bolt these plates to all this T-slot. So I've seen NYC CNC and tactical keychains and all them just use a drill to tap their aluminum instead of the handle. So we're gonna give it a try. I figure we'll test it out on the bottom sides of these ones since we're not going to use these, so in case it goes bad, using the drill to tap it will still be okay. A little cutting oil. Please work. So these are tapped to M5 for M5 by 16 is what's going to be in all these. Well, seems to be working. Nice and slow, don't hurt nobody. Oh, and this is just a cheap Harbor Freight tap, by the way. Hopefully it'll get me through all this, but if not, I guess we'll upgrade to a Meratool tap. So, lots of tapping in our future. Really should pick up one of them deburring tools. So M516s is what I got going in here. So that means, and these are 6mm plates, so that means we need 10mm depth. That's not too far really. Maybe I'll tape this off real quick. That didn't sound healthy. Yay! That works. Alright, 1,000 more to go. There we go. A little Sharpie mark on there makes it much easier than the tape that kept sliding off. That drill feels like it's going to light on fire, so better take a break. Both sides of these, all 4 of these need to be done. First one is done. So it turns out you can be a lot more aggressive than you would think. So just make sure you get plenty of oil. Make sure you start it off square. Start a little slow. And then you basically just gun it. Sometimes you can get all the way. Usually I get about halfway. So just for good measure, add one more drop of oil. Go full bore. And my battery dead. But it's just that easy. All four done. Alright, so just a quick recap. We drilled out the top and bottom column plates for M5 clearance. Made sure those were all cleaned up nice. And then we spent forever tapping M5 threads into the column T-slot. So we did all the holes in the 650 millimeter lengths, all the holes top and bottom, and then we did just the one side of the 590 lengths. And that is all for today. We'll see you next time. Later.